All right, everyone, welcome back. Again, good to have you here. You'll have to hear from me for another little bit here. So I'm going to talk for the next 30 minutes about business taxes, and in particular, the effect of business taxes on incentives to invest. There's a model in the PSL catalog that I've helped develop and help maintain, and that is called cost of capital calculator that helps with just this. So, as with my previous presentation, I'm going to start by just bringing up some online documentation. And so I'm going to go to ccc.pslmodels.org, and that'll bring up the documentation for this model called the cost of capital calculator. And this model is what is, again, what I'm going to show you as a useful tool to look at incentives the tax system places or affects for business investment. This model came about, I guess, several years ago, just maybe 2016. We started building this out. It's modeled after an old spreadsheet model that the Congressional Budget Office had, looking at the effects of capital taxation on investment incentives. So we basically liked that spreadsheet model, but wanted to make it more user-friendly and then also allow one to do simulations of alternative policies. And with that motivation came this cost of capital calculator. So what does it do? Well, it computes, as I guess the name implies, the cost of capital. And from that, other measures of the burden of taxation on investment incentives, such as the marginal effective tax rate, the marginal effective total tax rate, the effective average tax rate. So a number of different measures are computed here. These can be read about in kind of the overview of the model and its assumptions, first with just this equation for the cost of capital, and then with some of these other measures like marginal effective tax rates. But in short, what each of these measures are providing is a look into how the tax system distorts investment incentives on a forward-looking basis. So we're thinking about how incentives at the margin. So does the firm invest a little bit more, a little bit less? How is that affected by these the marginal effective tax rates imposed by the tax code through rates like the corporate income tax rate or personal tax rates on pass-through income, as well as non-rate law, such as how assets are depreciated or amortized over time. So all these complexities of the business tax system, from depreciation deductions to investment tax credits and other incentives for investment, are all captured and summarized through this marginal effective tax rate measure provided by cost of capital calculator. There's also effective average tax rate. So we're not just thinking about the marginal decision here, invest a little bit more or less, but just an average tax rate is also computed also on that forward-looking basis following Devereaux and Griffith. This is really important when we're thinking about policies that might, where we're really concerned about the location of capital. So is the U.S. competitive in an international context? We might be worried about that effective tax rate. Do firms locate here or locate somewhere else? Whereas the marginal effective tax rate is more relevant for decisions of or thinking about investment on that, what we would call intensive margin, a little bit more, a little bit less, rather than the extensive margin. Do you put it in the US or do you put it in Europe? But again, both those measures are things that you can compute from the cost of capital calculator. This documentation will kind of detail, again, the academic sources from which these measures are derived and so on. But where I'm going to focus my time today is on, how do we just interact with the cost of capital calculator, assuming we know what we want to measure out of it, marginal or average tax rates, for instance. How do we interact with that model? How do we tell the model to analyze different, policy than the current law baseline and so forth? Okay. So as with TaxBrain, we kind of have the same issue right now with cost of capital calculator. There used to be a graphical user interface web application. Again, financial support for that has dwindled, so there's not a freely available one at the moment. But we can interact this without any software in our machine. We can interact with it through a web browser via Google Colab notebooks. But we do need to, again, talk to the Python interface. However, what you'll find here is that the way we interact with this model is very similar to the way we interacted with TaxBrain, as well as other models in the PSL catalog that are built around the tax calculator package. of which cost of capital calculator is one. And so we're going to see a lot of similarities in terms of how we specify changes in tax law and how we call methods to compute or simulate the model and then look at the results. Okay, so I have a notebook, as before, I'll share the link to the Colab notebook. You can follow along. I have had some issues with this. There's kind of a package that Google Colab has updated that is making it difficult for me to render the visualizations there. But nonetheless, I'll share the link here in our chat in case you want to follow along in that notebook. Again, bearing in mind some visualizations may not produce because of a recent updated Colab that I'm still working to resolve. So I'm going to run these locally so you can see what those visualizations look like. But in principle, this, everything should, in general, be executing on Colab, and I will update that notebook in the near future to make sure it does execute with the current Colab environment. But I'm just going to switch and look at this notebook on my local machine. And here I am back in Visual Studio Code with this cost of capital calculator demonstration. Okay, so again, we're dealing with this through the Python API. So we've got to import a few packages here, a couple custom ones. One is the cost of capital calculator package called CCC. And then we're going to also import the tax calculator package. We're going to use a function from that. And tax calculator is something that is in general called from cost of capital calculator to find things like the marginal tax rates on pass-through income, on capital gains, and so on, which are all part of that calculation of those marginal effective total tax rates that cost of capital can report for us. So getting the full burden of the tax system on investments, both as done through the individual income tax code as well as through the corporate income tax code. Okay, cost of capital calculator itself, once we've imported those basic options, there's really like three ingredients to doing a simulation with cost of capital calculator. So those three ingredients are all going to be mixed together in this calculator class object. And those three ingredients are a set of model parameters that are going to be passed through what's called the specifications object, a set of depreciation parameters. Depreciation parameters can vary by industry and asset type, so they're very complex. So those are handled in a separate parameters object called the depreciation params object. So we got two sets of parameters representing essentially tax law as well as economic assumptions. And then the third ingredient here is your data. So this assets class produces a data object suitable for cost of capital calculator. I'll show you what that looks like, because in principle, you can pass in your own, but this just sets it up nicely, because what we're going to need is, or what we're going to want if we want to do a rich set of analysis, is we want to have the ability to look at things by asset type, by tax treatment. So are you a corporate or non-corporate, i.e. pass-through business, as well as different industries. And so this assets class object, which is the first thing I'm going to instantiate here, what it does is just essentially creates like a table, or in this case, what we're looking at is a Python data, pandas data frame that has by tax treatment, by BEA asset code, and by industry. It has the total amount of assets here, dollar value of assets, and then it's got the economic depreciation rates. And those are kind of the key things. There's also some other kind of industry labels and so on that can be useful for like helping understand what's in each category if you don't memorize the BEA codes. But the key ingredients here in this assets class object are having those economic depreciation rates, the amount of assets that are in that asset category by tax treatment, by industry. Okay, so for instance, the second row I've highlighted here, where we've got, this is corporate tax treatment in fishing, forestry, and related activities. And this is in the asset category is intellectual property in that. And there, I guess, in the BEA table, there are $0 attributable to that bucket. All right. But that assets data, that's what that's going to do. This is, several hundred rows, because we've got about 100 asset types, 100 of those BEA codes. And we're doing that all by industry, by tax treatment. So several hundred lines actually in this assets data frame that we're looking at. And we're looking here at just the first 5 rows of that. That second ingredient was this depreciation parameters object. We instantiate that with this cost of capital depreciation parameters class. And what that looks like is that's going to be the depreciation method and the life of the asset by year and by asset type. So we can have, these methods vary by year, by asset type, and so on. So the method, life, and system can all vary by year and asset type. And that's all done in this depreciation parameters class object. So we just instantiated that here. And again, this is just going to take current law. This is something, where you might want to look at changes to these depreciation rules going forward, and where you would update those depreciation parameters. So, maybe we want to switch these 5-year lived assets from, double declining balance at 200% to straight line depreciation starting in 2026. If we want to do that, we can update this parameters object, and we'll see examples of how to update these parameters in just a moment. But this is just setting up with our baseline current law view of that. Okay, then next we're going to create this last ingredient that is our other non-depreciation parameters of the model, and that's done with this specifications class object. Those, we've got those specified for current law for all years. And so we're going to pick a year to analyze here, and we'll set that to 2026. So we'll generate our kind of baseline tax parameters there. And then the calculator object, again, is going to mix all 3 of these ingredients together. So we've got our base parameters we just set, those depreciation parameters we did prior to that, and then the asset object we did initially. All right, so we'll mix those all together in this calculator object. And now it's all together. I called this base calc because, as you saw, we just took the specifications object for 2026, no other arguments. So we're just taking the baseline, current law baseline in this case. And we did the same for the depreciation parameters. And then, of course, the assets are just our data we're building off of. All right, and then we want to specify a reform policy. Okay, so we can do that in a number of ways. So cost of capital calculator, again, interacts with the tax calculator model. So we can change individual income tax parameters, like individual rates for pass-through income, say, or for capital gains, all of which are going to affect these marginal effective total tax rates we'll get out of our model. We can change all those just as we change them in tax calculator. So everything we went through with that tax brain example, and in fact, I'm linking to exactly that same URL now, so TCJA permanence. We're going to pass an object of that same format as we did in TaxBrain to cost of capital calculator. So this cell is just reading that URL, putting it in a dictionary called IIT reform. And now to pass that to our cost of capital model, we're going to, in this case, we're going to want to compare to our baseline current policy. So what we're going to do is create a new specifications object, also for year 2026, but we're going to pass it this change in individual income tax rates. So now we got in 2026, under reform params that we're setting in this line, we're going to have TCJA permanent. So we won't have the expiring provisions at the end of 2025. So we're going to, in general, right, this is going to mean we're going to have lower marginal tax rates on individuals and on pass-through business income for those individuals in 2026 than we would in the base params that we set above. So I'm going to set those reform params. And then I'm also going to not just change the individual income tax, and you can see this right now as running tax calculator in the background to compute marginal effective tax rates under this TCJA permanence. But I may also want to look at some business tax related policies. And so I can do that as well. Also going to pass those changes in business tax through a dictionary. So I'm going to call this dictionary biz reform. And I'm going to make essentially 2 sets of changes to how we treat, how we tax income at the corporate level. So I'm going to change the corporate income tax rate. So current law is 21%. This reform is going to knock it down to 15%. And under current law, we have in 2025, bonus depreciation is 40%. This is phasing out over time, so it'll be 20% in 2026 and then 0 in 2027. Something we might consider, or one might consider, is making or reinstating a 100% bonus depreciation for assets with lives 20 years or less. And those are those next few lines here. I'm going to change the bonus depreciation rate on 3, 5, 7, 15, and 20-year lived assets to 100%. All right. So I'm going to now, I want to have both this business reform and TCJA permanence together. How am I going to do that? Well, what I'm going to do is I've got this parameters object above, called reform params, where I instituted that individual income tax reform. I'm just going to update that. So update specification, passing this biz reform dictionary. And so that's going to change those business tax related parameters, the corporate income tax rate and those bonus depreciation rates. All right, and I'm going to now mix the three components together. I've got my new parameters that I've called reform params, which changes some individual provisions and changes some corporate provisions relative to current law. I haven't done anything with specific depreciation methods, so that DP object is going to remain the same, and I'm going to keep the same data, but I'm going to now, again, mix these all together in this new calculator object I'm going to call reform calc. All right. So we've got our policy parameters in reform params and DP, and then we've got that put together with our data in this assets object, and I mix them all together in this calculator class. All right. Now that they're all together, now I can do some things. I can do calculations. I can simulate the model. I can simulate how marginal tax rates have changed, for instance. So here I'm using the summary table method of the calculator object, and I'm going to compare the baseline with base calc to this change in policy, TCJA permanence, plus these changes of the corporate income tax rate and bonus depreciation. So here's a simple table that helps summarize what these changes look like. So we've got changes to marginal effective total tax rates between the current law baseline and this reform policy. So we can see that METTR for all assets and all investment types here under the baseline, and then under the reform, and then we've got the delta between the two. So almost a 10 percentage point reduction in this marginal effective total tax rate. That's coming from, again, all of the changes we've made: TCJA permanence, a lower corporate income tax rate, and 100% bonus depreciation. And the subsequent rows kind of break this out for how does this vary differently across corporations versus pass-through businesses. For corporations with the CIT rate cut, this is particularly large. So we've got a reduction in marginal effective total tax rates on the order of 15%. For pass-through businesses, we don't have that corporate rate reduction, but we do have some marginal rate reductions at the individual level and the bonus. So we're still finding 4.6% or so reduction in marginal effective total tax rates. And then we can see two differences across debt and equity financing here. All right, so that's just a basic summary, a table we can easily produce once we set up those two calculator objects for our baseline, current law baseline, and our reform. Again, we can produce that summary table very, very quickly. We might also want to visualize some of these changes, and there's handy functions in cost of capital calculator to do just that. All right, so here I'm going to create a what's called a range plot here to look at. Essentially, this is going to be helpful if we want to visualize kind of differences in treatment across asset types. So what these range plots are showing is for the baseline in blue and the reform in red, we're kind of seeing, the top percentile and bottom percentiles of those marginal, in this case, marginal effective tax rates. And then we've got the mean marginal effective tax rate, that dot in the middle of those ranges. And so we can see kind of how there are these, how the spread of the incentive to invest is varies across asset types, essentially. And then we've got it 3 columns separately for typically finance, or the historical mix of debt and equity, 100% debt finance and 100% equity financed. Right. So just to highlight some observations here, under current law, and this is less true under this reform policy, we've got debt financing is generally cheaper than equity finance, right? Because we can deduct the interest payments on that debt. We're also seeing that the range under current law, where there's bonus in 2026 is just 20%, is not that large. But when we add this bonus of 100% for those assets live 20 years or less, that range kind of explodes. We're going to have again, a much different tax treatment of a 5-year lived asset versus a building, say. And that's contributing to the spread under that reform policy. So there's, rates are lower on average under the reform, but there's also a bigger spread, meaning that there's more disparity across asset types in terms of how the tax treatment incentivizes those investments. And you'll see that the numbers here also can be negative. That is truly a negative marginal effective tax rate, i.e. the tax system subsidizing investments. And that's very much true for debt finance investments, but also some equity finance investments as well. All right, again, that happens with 100% bonus for sure. If we want to look at kind of specifically across industry, there again, and we can do this by asset too, but here I'll show you kind of a group bar plot where we're looking by industry. And this is, I've got corporate false, but let's just look at corporate true. And here we can see that tax treatment across industry and how it's varying. Again, and why is it going to vary across industry? Well, it's because industries have a different mix of asset types, right? And we've measured that in the BEA data. So we know, for instance, like, utilities or mining might use more heavy equipment, construction, or I guess maybe a better sense, some other services might have more reliance on buildings or longer lived assets. So there's going to be substantial variation in the treatment across industry, depending upon the mix of assets those industries use. Right. All right, and that can be summarized in this plot. But there's definitely the functionality if you want to make your own. So again, there's a handful of custom plots that are very easy to produce with that calculator object, as well as some tables. But we can also just dump the data, and you can see an example of this just in table format, where we're going to get all of these measures: effective average tax rates, tax wedges, user cost of capital, etc., dumped into a data frame, or you can save this as a CSV file or Excel file, open it up there and produce your own custom plots. Any way you want to slice these data, by type of financing, by corporate versus non-corporate, by industry, by asset, etc., by year. All of that, of course, is free to do, and you can just really just get that right from that calculator object, and just dumping out tables where you compute the values of everything, all those measures of the incentives, marginal and average tax rates, for example, by asset. And then with that, you can really, that is the input to all those figures and tables above. And so with that, you can produce any visualization you want. So just to kind of summarize what this notebook is illustrating, it's illustrating how you can interact with that cost of capital calculator through its Python programming interface. And really, you can see here, once you've set up that calculator object, you can produce plots and tables, and you can just dump all the data. And the real learning curve where that comes from is, how do you format these different policies? Okay. And we talked about tax calculator before, and those individual reforms and how you specify those. And I pointed you to that documentation. And for these business reforms as well, we've got on ccc.pslmodels.org, we've got the documentation for cost of capital calculator. It has these examples of changing these different reform options. And so you can see again how this is formatted. We've got one example here, but you can see the full list of parameters in the documentation. And then feel free to be flexible, update, bonus depreciation, update assumptions about inflation, update rates, treatment of inventories, first in, first out versus LIFO, et cetera. All of those are parameters that can be adjusted in this model. It's just a matter of, again, knowing the corresponding variable name and then setting it up in a dictionary like this to look at changes in those parameters. So hopefully this is helpful to you as you think about, how tax policy impacts investment incentives. Cost of capital calculator is your way to do that, or one way to do that. I think a relatively straightforward way to interact with. We've got, again, examples in the documentation. There are links to citations where this has been used in policy briefs and academic research where you can find further examples. But a flexible interface to look at business tax incentives under current law or other baselines, and then compare that to proposed reforms. All right, so with that, I'll kind of end that presentation. Happy to take any questions y'all have at this point.
Jason, I'll just throw one in.
Yeah.
I thought it was awesome that we were able to use this at the state level. It felt like a lot of what you were presenting there was at the federal level, but a lot of states wrestle with business tax reforms, and this was a really productive way to give states information on what that would do to kind of the business incentives in those states.
Yeah, Rick, thanks for mentioning that. So Rick has written a few nice pieces looking at state tax reforms in several states. You leverage cost of capital calculator to look at their business tax reforms, understand the investment incentives those would impact. And I'll note too, we've I'll link to in some notes I'll share after this workshop, but we've also used this in kind of an international context. So Tax Foundation has their tax competitiveness database where they have measures of the tax treatment of capital in at least all OECD countries, I think many other countries as well. And we've plugged those data into cost of capital calculator to look at those effective average tax rates, marginal effective tax rates across country. And so there is, again, the programming interface is flexible and can accommodate different data sources and so on. And so, yeah, the ability to use this at the state level or in the international context is also there. Again, I was highlighting today, again, with our legislative kind of agenda over the next year, I think there's going to be particular focus on federal tax policy, but there is the ability to use this model in other contexts as well. All right, Dorian's got a question in the chat here. Do we distinguish between permanent and temporary tax changes? This is a great question. And so they're essentially, we can do this analysis and cost of capital calculator as I did. That was all for 2026. You can run through every year and do that. But the model is set up, again, following like the Hall-Jorgensen cost of capital formula to kind of assume permanent. So if you put something in place in 2026, it's 2026 law permanently. 2027 is 2027 law permanently. It's not accounting for those temporary, like for instance, currently the phasing out of bonus depreciation. I guess that's less relevant in this context, but yeah, if there were temporary policies like a corporate rate change going back up, that would not, under the current specification, be captured. I am trying to work on that, and I haven't finished that. There may be an open pull request. Certainly, I have a branch of this model on my computer where I've been working on that, but that is not complete. I'm not sure, CBO Dorian, if you can answer that. I know Cody Callan was working on something like this years ago. I'm not sure the state of that, but it's again kind of what you need to do is you need to reinterpret the kind of that cost of capital formula in terms of something where there is temporary policy. So there's a mapping that needs to be made there.
Yeah, I mean, the reason I'm asking because we don't have that, so I was just curious whether you had thought about it as well, and it's something that we're trying to think about, but it's just hard to model.
Yeah. No, it takes. I wish I were better with integral calculus. That might help. But I got Cody's note, and then there's like this mapping too with like Hall-Jorgensen is a continuous time model, and now I think you kind of want to think more like a discrete time model with these temporary provisions. So again, that mapping needs to be made. And I've been working off. Cody had some notes years ago, and so that's kind of what I'm building from. Yeah.
Right. Thanks.
Yeah, great question. All right, well, with that, we'll take another 15-minute break. We're going to come back for